The displacement the displacement of a particle moving in a straight line depends upon time t, as x is equal to at cube plus bt square plus ct plus d. The ratio of its initial acceleration to its initial velocity depends upon. Okay, so again, a very simple question regarding differentiation. So we have x is equal to at cube plus bt square plus ct plus d. So we know that v is equal to dx by dt, or d by dt of x, which is equal to d by dt of at cube plus d by dt of bt square plus d by dt of ct plus d by dt of d. So v is further equal to a into d by dt of t cube plus b into d by dt of t square plus c into d by dt of t plus d by dt of d. So what we should understand here is that a, b, c and d are constants. That's point number one. Point number two, d by dt of t raised to n is equal to n into t raised to n minus 1. Alright, so if we apply these two, so we get a into 3 into t raised to 3 minus 1 plus b into 2 raised t, b into 2 into t raised to 2 minus 1 plus c into 1 into t raised to 1 minus 1 plus 0, because derivative of a constant is 0. So v becomes a into 3 into t square plus b into t raised to 1 plus c into t raised to 0 plus 0. So this can otherwise be written as v is equal to 3a t square plus 2bt plus t raised to 0 is 1, so that becomes c. So we have an expression for v. So let me write it down once again. V is equal to 3a t square plus 2bt plus c. Now what is a is equal to? Acceleration is rate of change of velocity, which is d by dt of v, which is further equal to d by dt of 3a t square plus d by dt of 2bt plus d by dt of c. So acceleration is equal to 3a into d by dt of t square plus 2b into d by dt of t plus d by dt of c. So acceleration will be equal to 3a into 2 into t raised to 2 minus 1 plus 2 into b into 1 into t raised to 1 minus 1 plus 0, and a is equal to 6a into t plus 2b. So this is what we have the expressions for a and b. Now the question is not to find the expression for a and b, expression for v and a. It is to find out the ratio of initial acceleration and initial velocity. So v initial will be now equal to, right? So v initial will be equal to v at t is equal to 0, which means 3a into 0 plus 2b into 0 plus c, and acceleration at t is equal to 0 will be equal to 6a into 0 plus 2b. So we can write that initial acceleration, right? So we can write that required ratio is A at t is equal to 0 upon V at t is equal to 0 is equal to 2b upon, so this is 0, this term is also 0, 2b upon c, which means this ratio is dependent only on b and c, and therefore the correct option is option C.